So this activity is the second on photosynthesis from Ulrike Hülting from Germany, shared with us at the European Science on Stage 2019. It's the second in a series of 4. They don't have to be done in any particular order. This one is called the ivy lift, and it involves using particularly ivy leaves. Ulrike suggests that ivy leaves are really good for this activity because when you punch holes to make these small ivy leaf discs, that the discs stay intact because the leaves are good and stiff. So you use a regular hole punch, and you need to cut or punch 15 or 20 discs from ivy leaves. These ivy leaves need to be freshly picked so that they've been actively photosynthesizing. And then when you collect your discs from your hole punch, this is what they look like. They're good and rigid. So I've put, you can punch about 15 of these. I've put 5 or 6 in here. And the remainder, from about 20, I've put in this syringe here. Now in the meantime, you need to have a 400 or 500 ml solution made up. It's just water, lukewarm water, not too cold so that photosynthesis is still going to occur, and just a pinch of bread soda, baking soda, sodium bicarbonate, and a couple of drops of washing up liquid, and to dissolved, and the sodium bicarbonate provides carbon dioxide for photosynthesis. So the ivy leaf discs that I have in our syringe here, I'm going to just half fill the syringe with some of this bicarb solution, and I'm going to put the plunger in, and I'm going to just push the plunger halfway, and then I'm going to put my finger over the end of the syringe, and I'm going to draw the plunger so that I create negative pressure for the leaf discs. So do this once, you can repeat it again, pull the plunger all the way down, and what happens is that the gases in the stomata in the leaf discs, as you can see, causes the leaf discs to sink. So when we then take our plunger out, so when we get our leaf discs out again, you split these leaf discs then evenly between both of your other 2 beakers. So just split them evenly, pretty much. Let's see, we can get another couple in there. Okay, so once you have your leaf discs in your 3 beakers, you can top up each of the beakers with your bicarb solution. And what you'll notice is the ones that have been cut directly from the leaf and haven't been treated with the syringe, with the negative pressure of the syringe, they float, whereas these 2 sets sink. So one of these, the 3rd beaker, I'm going to put in here. I'm going to put it into a cupboard or something, but I'm just putting it in here to keep it in the dark. So this is the negative control. These 2 are also for comparison, but this one I'm going to place then into a bright, both of these I'm going to place into a bright light. And then over time, what you'll see happening is that the gases in these leaf discs will build up as oxygen is produced during photosynthesis, and it'll cause the leaf discs to rise. So the result of this experiment shows that, well, a couple of things. Shows, first of all, that gases are produced by leaves during photosynthesis, that there are gases produced in the stomata. So the discs that aren't treated, that don't have the gases removed, they float from the beginning. The discs that have the gases removed but then are placed in the dark, they will not float. So because there's no light available for them, so they can't photosynthesize, so there's no gas production. But the discs that are placed in the light for a 1 or 2 hours. Actually, it only takes about 10 or 20 minutes usually. They'll rise during that time period. Now, what you can do is you can use this experiment to measure the rate of photosynthesis. So by timing how long it takes for the average leaf disc to float. And then there are a number of different variations that you could do with this experiment. You could vary the bicarbonate concentration to look at the amount of the effect of CO2 concentration on the rate of photosynthesis. You could vary the light intensity and see how long it takes for the discs to rise, and you can vary the temperature of the bicarb solution in order to measure the rate of the effective temperature on the rate of photosynthesis.